Welcome to this presentation of Course 2, Module 4 on inter-VLAN routing. We're going to describe the different options and methods for configuring inter-VLAN routing. We'll also use Packet Tracer to configure both the router on a stick and the Layer 3 inter-VLAN routing methods. Inter-VLAN routing is the process of forwarding traffic from one VLAN to another VLAN. As you may recall, VLANs operate at Layer 2, and one VLAN cannot communicate with another VLAN unless there is a router or another Layer 3 device to provide routing. There are three inter-VLAN routing options. The first method, which we are referring to as legacy inter-VLAN routing, used a router with multiple Ethernet interfaces. This method required a dedicated interface for each VLAN. Since most routers don't have a lot of Ethernet ports, this solution does not scale well, and it is not implemented in today's switched networks. The second method is called router on a stick. This method requires only a single Ethernet interface. It uses sub-interfaces to route multiple VLANs over a trunked line. This method is scalable up to a medium-sized business, but does not do well over 50 VLANs. The most modern method utilizes Layer 3 switches and switched virtual interfaces to route multiple VLANs. This method has its advantages. It is the fastest method, has the least latency or delay. There is no need for an external link from switch to router. The only real disadvantage is that Layer 3 switches are more expensive. So let's take a look at the configuration for router on a stick. This is an example of router on a stick. There's trunk lines configured between the switches and between the switch and the router. Interface gigabit 000 is configured with sub-interfaces for the three VLANs on the network. So let's take a look at how this works in action. Using Packet Tracer, we can simulate how this works. We have a multi-switch network here with 4 VLANs. Now, the connections between the switches are already trunked. So you could ping within each VLAN. Try that now. See, we can ping from this PC to this PC on VLAN 10. Can't ping from VLAN 10 to VLAN 20 because we haven't set up router on a stick yet. We're going to do that. So let's start with the configuration for the router. We'll start by setting up the sub-interfaces on gigabit 01. And that's done by specifying gigabit 01 dot, and we'll use dot 10. To type in encapsulation.1q, and we'll specify the VLAN ID, which is 10. It's listed up here. We'll assign this an IP address 192.168.10.1. Nope. And then we'll set up this next interface. And this will be for VLAN 20. And we'll also set up the native VLAN as well. Forgot to type in the encapsulation.1q. And now we will enable the interface. Now we're not done yet because we have not created a trunk line here. So we need to go up to the switch. And that is interface gigabit 01. Switch mode trunk. Assign the native VLAN, and we will also define the VLANs that we're allowing over the trunk. Okay, and last, we do need to go on to the hosts and assign a gateway. Right, and these have been all set up now with the default gateway. And we can still ping from between VLAN 10, but we should now be able to ping between VLAN 10 and VLAN 20. And that's successful. So that's how a router on a stick works. Inter-VLAN routing uses the router on a stick method is the simplest to implement, especially for small and medium-sized organizations. However, a large enterprise requires a faster and more scalable solution to provide inter-VLAN routing. Enter the layer 3 switch scenario. Here, two PCs on different VLANs are connected to a layer 3 switch. The layer 3 switch will provide inter-VLAN routing services to the two hosts. And we can also do this in Packet Tracer as well. Here we have multiple PCs, 3 different VLANs. I've created the VLANs on the multi-layer switch we need to create the VLANs on the multi-layer switch. So let's go ahead and do that first. I'll just create the VLANs with them being named to the default VLAN 10, 20, and 30. And just like as if we were creating management VLANs on a switch, we just go interface VLAN 10 in this case. Assign this one IP address of 192.168.10.1. Okay, now let's configure the access ports for the hosts. We're going to configure all the ports as they are listed here. So 10 through 14 will be on VLAN 1, VLAN 10, etc. Interface range. Now these are fast Ethernets. And switch port mode access. Switch port access VLAN 10. And last, we do need to enable routing. Try that again. IP. Okay, routing. And let's see how that worked. Okay. So within the VLAN works. Let's try outside from the VLAN. And that's not working because we have not set up default gateway. And that was successful. And the default gateway is the SVI that's set up, the switch virtual interface that is set up on the multi-layer switch. And now we're able to ping across the network. This method is faster than the router on a stick because the switch can route VLANs without the need of an additional router. So there's not an additional step here. It's going to the switch, and that's being routed from within the device. And so there are a number of reasons why inter-VLAN configuration may not work. This table lists some of the issues and the commands that will help identify them. Common issue when dealing with router on a stick is trunk port issues. This table is in section 4.4.1 in the online book, so you should become familiar with these commands. And that concludes this presentation of inter-VLAN routing. Thank you and have a great day.